to complete the square. That's step number 3 to complete the square. What we end up with is something that looks like this, and we have to come up with the C value that makes this a perfect square trinomial. Now, how do you come up with that C value when you go to complete the square? Just as a reminder, you take half of the middle number and then square it. So half of 20 is 10. 10 squared is 100. So in order to make this a perfect square trinomial, you would have to have your C value as 100. That makes this a perfect square trinomial. Same here. Again, to make a perfect square trinomial, you have to look at half of that middle number and then square it. So half of 8 is 4, and 4 squared is 16. So in order to make that a perfect square trinomial, your C value has to be 16. And then it says, recall, to factor a perfect square trinomial, if you know what a perfect square trinomial is, you should understand that a perfect square trinomial comes from a binomial all squared. Now, how do we check to see that something is a perfect square trinomial? Well, something is a perfect square trinomial if the first number is a perfect square and the last number is a perfect square, and if you take the square root of this, it's just x. The square root of 25 is just 5. 5 times x is 5x. Double it, it's 10x. So we know that's a perfect square trinomial. So if we went to go to factor this perfect square trinomial, we know it comes from a binomial squared. What goes inside here, the square root of that is x, square root of that is 5, and there's a negative sign in the middle. Now, of course, you don't have to do this the way of figuring out a perfect square trinomial. You can just simply factor that using product sum integer, the product of that being 25 and the sum being negative 10. And you would understand that the two numbers that multiply to 25 and add to negative 10 are negative 5 and negative 5. So you could definitely factor those regularly, but it's very important to understand what a perfect square trinomial is. So looking at this example here, how do you factor this? Well, we can go and factor this using just regular product sum integer if we wish, but some of you may have noticed that's a perfect square trinomial. See, this is a perfect square and so is that. The square root of this is just x and the square root of that is just 4. X times 4 is 4x. Double it is 8x. So this comes from a binomial all squared. Square root of that is x, square root of that is 4 with a positive sign in the middle. And I'll let you figure out if this one's a perfect square trinomial, and if it is, to factor it using the technique of factoring perfect square trinomials. Now, steps to complete the square. You have to understand how to complete the square. So I gave an example, a brief example here on the side with the steps. So the first step is group the first two terms. So that's this right here. Group the first two terms. So all I did was put brackets around the first two terms. Step number 2 is factor out the a value. The a value is the number in front of the x squared. So what I did was, from these two items, not from the 11, but from these two items, I factored out a 3. Factoring out a 3 from the first one, this divided by 3 is x squared. This divided by 3 is 4x, negative 4x. The 11 just stays hanging out the entire time all across the question. Continuing that, number 3 says to complete the square inside the brackets. So we're doing exactly what we did up here, which is completing the square, making a perfect square trinomial. However, it's important that you understand that you cannot change the question. So in order to not affect the question in any way, when you complete the square, you have to figure out the number that makes that a perfect square trinomial inside, but you're going to add and subtract that number. So from grade 10 we learned how to do this. Now if I take a look at the 4, half of 4 is 2, 2 squared is 4. So I add 4 and subtract 4. That doesn't change the question at all. But what it does is it makes these three first numbers a perfect square trinomial. Step number 4 is factor this perfect square trinomial. And that's exactly what we did up here, factoring perfect square trinomials. You know this is a perfect square trinomial because you made it. So where does that come from? It comes from a binomial all squared. Notice the 3 still there, the -4, the 11. But this comes from a binomial all squared. Square root of that is x, square root of that is 2 with a negative sign in the middle. And so then my next step is expand and simplify. So the next step is to expand, multiply the 3 in here. You're not going to multiply the 3 inside these little brackets because it's all squared. So 3 times this is just 3 times that. 3 times -4 is -12. And then you have plus 11 hanging out at the end. Still all the way throughout the question. Add those two things together at the end and you get -1. So this is the function in vertex form by completing the square. So let's take a look at the next examples. These are the examples that you're actually going to complete. So it says here, complete the square and state the coordinates of the vertex. So these two things are given in standard form. We're going to complete the square in order to come up with vertex form. So let's take a look at the first one. Again, let's follow the rules. The rules are, first step, step number 1, group the first two terms. So I've grouped the first two terms. Step number 2, factor out an a value that is in front of the x squared. Well, there is nothing in front of the x squared, just a 1, so I actually do not have to do this step. There's nothing to factor out. Step number 3, I am going to complete the square of what's inside. So I'm going to leave some space here and I'm going to complete the square. How do you complete the square? Again, half of 8 is 4. 4 squared is 16. So I'm going to add 16 and subtract 16, making the first 3 terms a perfect square trinomial. The next step is to factor that perfect square trinomial. So this will be y equals, and you're going to have here, this perfect square trinomial comes from a binomial squared. The square root of that is x, square root of that is 4, with a negative sign in the middle. You still have this minus 16 hanging out, and you still have this plus 12. There was step number 4, which is re-multiply the a value in here, but there is no a value, so you don't have to worry about that. So the last step is adding those two things together, which gives you -4. So this is that formula in vertex form. You could obviously give me the vertex now of this thing, the vertex of this thing. H is +4 and K is -4. So the vertex is 4, -4. Moving on to question B, we can take a look at question B, and question B is the exact same thing. Put this into vertex form. So step number 1 is group the first two terms. I actually like grouping with square brackets, and you'll see why later because you're going to have brackets within brackets. Step number 2, factor out the number that's in front of the x squared. There actually is a number this time, it's a 2. So I'm going to leave this here. The 6 is going to be here throughout the entire problem. But remember to factor out the -2 from both of these terms that you've grouped. This divided by -2 is just x squared, and this divided by -2, don't forget that, is -2x. Step number 3, I'm going to leave some space and I'm going to complete the square of what is inside here. Complete the square, half of 2 is 1, 1 squared is 1, so I'm going to add 1 and subtract 1, making the first 3 terms a perfect square trinomial. Step number 3 is factor the perfect square trinomial. So I'm going to leave everything the exact same, but this thing here comes from a binomial all squared. The square root of that is x, and the square root of that is 1, with a negative sign in the middle, because there's a negative there. Continuing this, the next step asks us to re-expand, re-multiply this -2 back in here. -2 times the first thing is -2 times the first thing, and -2 times -1 is +2. And you still have the +6 hanging out, and the last step would just be to add the 2 and the 6 together to give you 8. So this is in vertex form. Of course, you can tell me the vertex of this thing. The vertex is hk. H in this case is positive 1, and k in this case is 8. So the vertex is 1, 8. And that is completing the square of these two things in order to put this into vertex form. Now, if you take a look at the next question, question 2, it says to use the equation x equals negative b over 2a to first find the equation of the axis of symmetry and then find the coordinates of the vertex. So I'm going to do the exact same thing, just in a different way. I'm going to put these exact same formulas. Notice this formula and this formula are the exact same. That formula and that formula are the exact same. I'm going to put these two things into vertex form, but in a different way. Instead of completing the square, I'm going to use the equation of the axis of symmetry to find the vertex. And of course you have to know how to do both ways, because if a question specifically asks you to do completing the square, you must be able to complete the square. But if the question doesn't say anything except putting this into vertex form, you can do either of these two methods. So this method here, putting this into vertex form, the first thing I'm going to do is figure out what the equation of the axis of symmetry is. And I know that the equation of the axis of symmetry is negative b all over 2a. So this is going to be x equals negative, and my b, be careful, is negative 8. So that's negative 8 all over 2 times a is 1. So x is equal to, a minus and a minus becomes positive 8 all over 2. So x is equal to 4. 4 is the equation of the axis. I know that the vertex lies on x equals 4. So I know that the vertex is 4 something. I just have to figure out what that something is, what the height is. So I'm going to plug in x equals 4 into here to figure out what the height of the vertex is. So I have y equals x squared minus 8x plus 12. And if I plug in a 4 for x, I'll get y equals 4 squared minus 8 times 4 plus 12. So I get y equals 16 minus 32 plus 12. So y is equal to, that's going to be negative 16 plus 12, which is negative 4. So the vertex is 4, negative 4. Now, what is my a value? My a value, I know my a value is just a 1. It's in front of the x squared. I now have enough information to put this into vertex form, because I know vertex form is this. And I know my h and my k, and I know my a. So this is y equals, my a is 1, x minus h is 4, all squared, plus k is negative 4. Now, you wouldn't write the negative 1 out in front of here. You could, but you don't have to. That is your final answer. And of course, that's exactly the same as up here. Much easier this way. Let's look at the next one, which is y equals all this, and I'm going to put it into vertex form again very quickly. Using the equation of the axis, which is x equals negative b all over 2a. So this is x equals negative, b is 4 all over 2 times a is negative 2. So x is equal to negative 4 all over negative 4, or x is equal to 1. So I know that the vertex is 1 something. I have to figure out the height of the vertex. I'm going to plug in x equals 1 in here to figure out the height of the vertex. So I'm going to rewrite this formula, and I'm going to plug in x equals 1. So this is y equals 2 times 1 all squared plus 4 times 1 plus 6. So y is equal to negative 2, 1 squared is 1, 4 times 1 is 4, plus 6. So essentially I have negative 2 plus 4 plus 6, and that is equal to 8. So I know that the vertex is 1, 8. What is my a value? My a